Worked example 7, Kirchhoffs Current Law. Question 1, determine the unknown current. We have a node with some known currents coming in and some known currents coming out and an unknown. So the way Kirchhoffs Current Law works is we have the total sum of currents coming in, so the sum in must equal the sum of currents coming out. Think of it as total going into a node must equal the total amount going out. So if we've got 5 amps coming in, denoted by the direction here, we've got 2 amps coming out and we've got an unknown coming out, then we can say, well, we've got 5 coming in equals 2 plus our unknown coming out here. I is going to be 5 minus 2, which is 3 amps. Question 2, determine the unknown current IA. And we've got a slightly different arrangement here, just to kind of mix things up a little bit. It doesn't really make any difference. We've got a node and we've got 3 branches coming out of it, or 3 currents coming out of it. Now the fact that there are slightly different angles and all that kind of thing makes absolutely no difference whatsoever. We've got 10 amps coming in, we've got 2 amps leaving up here, 3.5 amps leaving down here, and current IA in the middle. Same again, sum in must equal the sum coming out. Okay, we can't magic up current from nowhere and we can't lose current from anywhere. It always has to equal. So in this case, 10 equals 2 plus IA plus 3.5. So we can go ahead and subtract the 2, subtract the 3.5, and that's going to leave us with IA being equal to 4.5 amps. Question 3. In question 3 here, we've got a little diagram with 3 resistors in parallel with each other. I1, I2, I3, and this is our IS. We're asked to determine the total supply current if I1 is 200 milliamps, if I2 is 600 milliamps, and if I3 is 1.2 amps. So the thing to remember with current in parallel is it splits down each of the branches. So it gets to this node here, and this node is basically the same node as we saw before, where we've got our current coming in and it's splitting down 3 different branches. Here in this case, the current's coming in and it's splitting down 3 different branches. So we can work backwards here to say that the sum in must equal the sum out, and our supply current is the sum going in, and the sum coming out is 200 milliamps plus our 600 milliamps plus our 1.2 amps. Okay, so when we add all this together, we get 800 milliamps plus 1.2 amps, so that ends up giving us a total of 2 amps as our supply current.